Hello, my math friends. So today we're going to take a look at applications. So we've already talked about the three primary trigonometric ratios being sine, cosine, and tangent. We've talked about the fact that we can solve for unknown lengths and we can solve for unknown angles, and that really every question we do in trig gets set up the exact same way, which is we'll go like sine of the angle equals the ratio and then solve for whichever piece we don't know. Now, what we want to do with today's lesson is we want to go teach you a few more words, a few more phrases, just to help you in your understanding, okay? So first one is solve the triangle. So to solve a triangle means to determine the measures of all the missing angles and the lengths of all the missing sides. So far, up to today, we've only ever asked you to solve for one thing. And we've labeled it as X, or we've labeled it as Y, or we've labeled it as theta. And that was the communications for you to say, hey, find this for me. Now we're going to ask a question where we just say, solve the triangle. And you'll always get three things. So there are 6 things in a triangle. There are 3 sides and there are 3 angles. So 6 things altogether. I can give you any 3 of those, and you now have the ability to give me the other 3. Okay, so when you see the phrase solve the triangle, that's what you're doing, is you're trying to figure out everything that was not given to you in the first part of the question. So when you start to answer a question, always draw a diagram first and write down the unknown information. So whenever possible, do not use something that you have solved for as part of the next step. And I talked about that a couple lessons ago. If you messed up on the first part, you have automatically messed up on the next one, and you won't be able to receive marks for it if there had been a better way to do it. Okay, so just be careful of that. Okay, so solve the following triangles: round angles to the nearest degree and lengths to the nearest hundredth. So I have the 3 things I've been given here is the 90-degree angle, I've been given the 42 degrees, and I've been given the 15 centimeters. Okay, so doesn't matter which one I'm doing first. I might actually pop up here and solve for angle A first. I know that all angles in a triangle have to add up to 180. So I can just go 180 minus 90 minus 42, and that will give me my angle A. It's important to me that you are comfortable with this. That little symbol just means the measure of angle A. Okay, angle A equals 48 degrees. Okay, so the next one I'm going to do, we're going to head over to C and try and look for C. So C is my hypotenuse here. And so what I did was I said, okay, if that's 42, my 15 is opposite and my hypotenuse is right here. And so I'd be looking for opposite over hypotenuse, and that would need the sine ratio. So I say sine of 42 equals 15 over C. I will multiply both sides by C to get rid of the division of C. And then I will divide both sides by the sine of 42. So C ends up being 15 divided by the sine of 42. That is 22.42 when rounded to the nearest hundredth. Then the last thing I have to solve for is A, side A right here. I'm still going to use what I was given. So 42 degrees, this is opposite, this would be adjacent. So I'm going to do it using tan. So tan of 42 degrees equals 15 over A. And then again, multiply both sides by A and divide both sides by tan of 42. And that gives me A is 16.67 centimeters. All right, now solve this guy. Well, first thing I'm going to do is I'm going to tackle this side here. If you have a right triangle, a triangle with a 90-degree angle, and you know 2 sides, you can just use the Pythagorean theorem to get the 3rd side. So I'm going to go d squared equals 42 squared plus 31 squared. That means d squared is 2,725. Square root both sides and round to the nearest hundredth, 52.20 meters when properly rounded. Now I'm going to either solve for angle E or F. It doesn't really matter. Both have the exact same information. So I started with E. Looking at angle E, the 31 is opposite and the 42 is adjacent. So I know I want tan. So I go tan of E is 31 over 42. Now I will arc tan both sides. So E ends up being the tan -1, or the arctan of 31 over 42, and I stick that in my calculator and get 36 degrees. Now, you may be tempted, remember the note I put at the beginning of this slide, you may be tempted now to just say, hey, why don't I just go 180 minus 90 minus 36 to get F? I don't want you to do that in case the 36 is wrong, okay? So let's look at F, pretending that we've never dealt with E yet. So given angle F, this is 42 meters is opposite, and then this guy's my adjacent, so I'm still using tan, but now it's 42 over 31. So F will be the inverse tan of 42 over 31. When I put that in my calculator, it's 54 degrees. Now, as a check, you can now take that 54 and add it to 30 and add in the 90 and make sure that you get 180, okay? If you do get 180, that's gonna feel good that you've done it right. Okay, so now some really important vocabulary words for you. Angle of elevation is the acute angle. Remember, acute means it's less than 90 degrees. The acute angle between the horizontal that passes through the eye level and the line of sight to a point that is above eye level. This is also sometimes referred to as the angle of inclination. So elevation and inclination mean the same thing. Angle of depression is the acute angle between the horizontal line that passes through eye level and a line of sight to a point that's below eye level. So elevation and inclination involve lines going up. Angles of depression involve lines going down. Now, the really important thing here is that you have to understand that they both deal with a horizontal line. Students usually have no problem with angles of elevation and inclination. They get that fairly easy. They really struggle with angle of depression because of the way they set up their drawing. They end up inevitably putting the angle of depression with a vertical line instead of a horizontal line, and then it's not an angle of depression and it ends up being wrong. So you got to be super, super careful of that, okay? So in my example here, this is a common question that we might ask you, and what happens is lots of kids want to say, oh, okay, this looks so cool, here's my angle of depression. No, that's not your angle of depression. Your angle of depression is actually outside the triangle here, because it has to form with the horizontal line. So here, that dotted horizontal line there, that's what's going to form this angle of depression, okay? Now, it's helpful to know that the angle of depression and angle of elevation will always be the same measure in the same example, okay? So, I just want to draw that for you here for a second. Take a look at this. If I was to just put in two lines, okay, and then I was to go, this is going to take you back to junior high days for a second, where this is essentially a transversal line over two parallel lines. Now, here's what I want to show you. I'm just going to switch the colors here. So this might be that example I just showed you of the cliff and the boat, okay? So here's my boat, okay? And we were talking about an angle of depression right now. And so the angle of depression is right here. But from junior high, you probably talked about alternate interior angles, or maybe you heard the Z theorem. Anytime you see this Z, those angles equal each other, and that guy there is the angle of inclination. So in any given scenario, the measure of the angle of depression and the measure of the angle of elevation will be the same thing. So once you've established where your angle of depression is, if it ends up being outside of your triangle and you're like, what do I do with that? Put the same angle as an angle of inclination, and then you can solve from there, okay? So let's go back to this question then. The string of a kite is 105 meters long. The kite is anchored to the ground. The kite is 90 meters high. I actually asked you this question a couple of days ago, but I said, what is the angle formed with the string and the ground? Now I'm just saying, what's the angle of elevation? Because you have to understand that the angle of elevation ends up being with a horizontal and a line going up. Well, that is the angle with the string and the ground, okay? So there's my diagram that I'm going to draw. There's my angle of elevation. And opposite over hypotenuse, I'm going to use sine to solve it. I'm going to arc sine and get 59 degrees. Okay? The angle of elevation is 59 degrees. Nika is rock climbing, while Ross is belaying. When Ross pulls the rope taut to the ground, the angle of depression is 73 degrees. If Ross is standing 8 meters from the wall, what length of rope is off the ground? So we have to create a diagram. I would pause me here and you try the diagram yourself. So we're looking at something like that. Remember that the angle of depression forms with the line going down and a horizontal. So I stuck in the dotted line just to represent where the horizontal was, so I could see that angle of depression. Now, if I have the angle of depression, I also have the angle of elevation. So I'm going to put a 73 there as well. And now I'm easy to solve for this length. I know that the 8, given this angle here, I know that the 8 is adjacent, and the x right now is my hypotenuse. So adjacent over hypotenuse, I will solve this using cosine. So cos of 73 degrees equals 8 over x. I'm going to multiply both sides by x and divide both sides by cos of 73. And that will give me 27.36. So the length of the rope is 27.36 feet. Okay. The Calgary Tower stands 191 meters tall. That is a true statement. Mayor Nenshi has proposed that a slide be constructed from the top of the tower down to Center Street. That is not a true statement, but I think would be a really cool idea. For safety reasons, the angle of elevation must be 40 degrees. How long is the slide and how far away from the base of the tower will you end up? So there's 2 questions here. We're going to treat each one separately, but it'll be the same diagram that we deal with for each question. So go ahead and draw your diagram. You have something that looks like this. The first question, which I've labeled with the A, is how long is the slide? So this will be my A. And then how far away from the tower do you end up? This will be my B down there. Okay, so if I'm going to solve for A first, looking at that 40 degrees, which is my angle of elevation or inclination, then 191 would be opposite and the A would be hypotenuse. So I'll solve using sine. So sine of 40 is 191 over A. Multiply both sides by A, divide both sides by sine of 40. You end up with A equals 279.14. So the length of the slide is 279.14 meters. Okay, and now how far did I end up? Well, the B is my adjacent. So 191 is still my opposite. Who uses opposite and adjacent? That would be tan. So tan of 40 degrees is 191 over B. Multiply both sides by B, divide both sides by tan of 40, and I get B is 227.62. So the base of the slide is 227.62 meters from where you end up. Okay? You are standing on a 50-meter cliff overlooking the ocean. You see a ship out in the sea. The angle of depression between you and the ship is 42 degrees. What is the distance from the boat to the cliff? Okay, so pause me for a second and try the diagram. I really want to see if you are able to deal with this angle of depression properly, okay? So what you should have gotten is this. Remember, the angle of depression has to form with a line going down, but with a horizontal. If you put it in beside the cliff, that's not forming it with a horizontal, that's forming it with a vertical, okay? So once you've established the angle of depression is here, and that's 42, you also now know that the angle of elevation or inclination is 42, and then you can work with this triangle here. So I know that the 50, given this 42-degree angle here, the 50 is opposite, and my x value, my unknown, is my adjacent, so I will solve this using tan. So tan of 42 equals 50 over x, multiply both sides by x, and divide both sides by the tan of 42, and I end up with 53.53. So the distance from the boat to the base of the cliff is 53.53 meters. Okay, so nothing really new here today. It's just understanding these 3 kind of new phrases. Solve the triangle, which means get everything. Find the angle of inclination and elevation and the angle of depression. Okay, as long as you're comfortable with that, nothing else has really changed in how you set up the question and how you solve the question. So give these guys a try for homework And if you have any questions, let me know. Take care.